Here's how we're going to start review today. I'm going to call on one person, and they're just going to give me a random point. Positives, negatives, I don't care. Give me something. We're going to plot that point, and then to that point, we're going to do each one of these transformations. All right, and see what our new point is. All right, so that's the goal. Somebody's going to give me just a random point. I don't even know what it is yet. And then we're going to go through. All right, what if I reflect? I just gave that away. What if we do this? What if we do this, this? What's our new point? Okay, so let's do this. Give me any point you want. Please don't give me 0, 0. Don't be that person. All right, 7. Big job here.
7, -3.
Woo, all right, I like it. And a negative in there too. All right, everybody. 7, -3. I will do the first row with you. Somebody else will pick a new point, and you're going to do that one on your own. All right, so we're going to take 7, -3 and transform it 6 different times. First person I want. What's it asking me to do here? All right, because I can't help you with the symbols tomorrow. What's it asking me to do? What am I asking you to do first? 13, what am I asking you to do first? Okay, reflect over the X. Go ahead, everyone, however you want to do that. Reflect it over the X-axis, and then I'll ask somebody what my new point is. All right, what is my new? Let's see, I gotta think about this. X-axis, that stays the same, and that changes. Okay. So if I reflect over the X-axis, what's my new point? 11? 7, +3. Good. 7, +3. Next up, what am I asking you? And remember, we're always going to go back to the original point here that Kara gave us. All right, we're going to go back to the original point. What am I asking you to do in the second one here? 5, what am I asking you to do?
Reflect it over X3.
X equals 3. All right, we got to know what type of line that is tomorrow. Can't raise your. You're going to keep going?
Yeah.
Oh, sure.
Vertical.
That's a vertical line. Yep. All right, that's a vertical line, everyone, going through 3. All right, go ahead. Make sure you go back to the original point, 7, -3. All right, where'd you end up when you're ready? 2, where'd you end up?
I didn't get it.
All right, count your coordinates and let me know. Count how far away you are from that vertical line, X equals 3. Go that distance on the other side, and let me know what that point is. There's my point.
Okay.
What type of line is X equals 3? What did we just go over?
Vertical line.
How many units away is that point from that line? From here to here. 1, 2, 3, 4. So I go 1, 2, 3, 4 over here.
Okay.
What's my new point?
-1, -3.
That's all there is to it, Nate. All right, that's all there is to it. Everyone good? Next one, what am I asking you to do here? Again, you guys are starting to see how big notation is. What am I asking you to do here? 9? Translate. And you want to go bonus here, everyone? You want to go, what type of notation is that? Because I may ask you to leave it in this type of notation on tomorrow's quiz. Vector notation. Good. Vector notation. It's a translation. One more time, Elliot. What's it telling you to do? Left 2 up 3. Good. Go ahead. Left 2 up 3, everyone. That's called vector notation translation. Vector notation. I may have you leave an answer in vector notation tomorrow. Left 2 up 3. Two. Here we go, Nate. Redemption. Where do you end up? If I take 7, negative 3 and go left 2 up 3.
Can you stop giving me the answer?
Thank you. Yeah, Anna, why don't we cut it? It's not a partner quiz tomorrow.
Is it 5-0?
5-0 it is. Done. Everyone good? All right, what's the next one asking me? Let's roll. What's the next one? I'm going to have a backup question after this. 9, what's this next one? Oh, just rotation of how many degrees? Negative 90. Where am I going? Clockwise or counterclockwise then? Where do I have to turn my paper? 8, clockwise or counterclockwise? This is clockwise, right? Clockwise. So I should be turning my paper to the clockwise. Turn it to the right. Or memorize the rule for, hey, if you memorize the rule, remember this is the same as a rotation of positive 270. If you memorize the rules. If not, you're going to have to turn your paper to the right. So everyone turn your paper to the right, 1/4 turn to the right, and look where your point is now. Let's see, can I do that? One-quarter turn to the right. Yeah, I think I got it. Okay, where do we end up? 3. Spence, where do you end up?
-3.
Yeah, that's where we end up. Real quick, if anybody ended up with 3-7, you turn your paper to the left 90 degrees instead. Okay, got to turn your paper to the right. Next one, what's it asking me to do here on the 6? What are we looking to do here?
Move it to the left 3 and down 4.
This is another form of a translation. We don't have a name for this, but the capital T tells me translation. Left 3, down 4. All right, let's roll. Left 3, down 4. And when you're ready, left 3, down 4. Spence, 3.
-4, -7.
4, negative
-7.
7. Yep, good. No issues yet, guys? And then the last one. What are we looking to do here? What am I asking you to do? 2. Nate, what's this saying here? Lowercase r.
Reflection.
Over what line? What's the subscript here?
Y equals 8x.
Okay, make sure we prep tomorrow here, boss. Okay, got to prep tomorrow. Don't have no counting, right? Just remember the rule. Look back if you need to. You got to remember this is a rule. What do I do to my coordinates when I reflect over y equals negative x? What is my rule here? Look back in your notes. It's in there. It's in there. We wrote it down. You got to remember the rule for this. Y equals negative x and y equals x. You got to remember the rule tomorrow. Something I do to the coordinates. Four.
Flip the coordinates and
Go ahead.
3, -7.
Flip the coordinates and change their sign. Flip coordinates and change their sign. Good, everyone. Good. All right, one more time, but you're on your own now. All right, you're on your own. Somebody pick a new point here. Let's go 13, new point. 5-2 it is, everyone. 5-2. And go ahead through the same steps. 5-2. I'll give you guys solid 3-4 minutes here. And then we're going back to your packet. Actually, I should probably do these too.
There's 6 of them.
All right, can I get 6 different people? What do you think? Can I get 6 different people going? Reflection through the x-axis. Where are we? 12. Where are we? Reflection through the x-axis.
5, -2.
Good job. Got 5, -2 over the x. If you ended up with -5, +2, that was the y-axis. Make sure you got the right axes. Vertical line x equals 3. 9. Vertical line x equals 3. 1, 2. Translation, -2, 3. That's called vector notation again. I end up where? for -2, 3, 3.
I think, -2, 3.
-2, 3. Okay, you went down 2, right 3. So I'm at 5-2, Spence. At 5-2. Sorry, right 2, down 3. Sorry, right 2, down 3. I left 2, up 3. Left 2, up 3. I'll get it sooner or later.
I got 3 negative.
I got the 3 part. Now you got to go up 3, though. Right? This 3 tells me to go up 3 units on the y-axis. So if I'm at 2 and I go up 3,
3 negative.
why are you still in the negative, Spence? Okay, you're at 2, right? 5-2.
It's 3, 5.
Okay, you good?
I wrote it wrong.
You good now?
Yeah.
All right. Oh, here we go. Rotation, -90, turning our papers to the right. To the right. 1/4 turn. 1, Anna?
Um, 2 -5.
2, -5. Questions out here? Negative translation, -3, -4, 10, 2, -2. And then finally, how about a reflection over the line y equals -x? 13? What? Did you go yet? Okay, good. Sorry, Charlie. Go ahead.
-2, -5.
All right, there you go. Am I going to ask a chart like this tomorrow? No, but there's going to be questions. Reflect this, rotate this, translate this way. All right, let's go into your packet now. Let's go to the review in your packet. I want to do a few questions with you so they don't surprise you, and the rest is on your own, which is also the assignment tonight. When you guys get there, first one I want to do with you is problem number 6. Problem number 6. We just haven't talked about anything like this, so I don't want to surprise you. Regular polygon, just a reminder from unit 4, way back in the day, regular polygon, all sides and all angles measure the same. All right. Which angle of rotation will carry the figure onto itself? Here, first of all, what's it mean to carry a figure onto itself? Here's what it means. I want your guys' help. How many degrees can I rotate this figure and see what it looks like now? Everyone sees what it looks like before I rotate it. How many degrees am I able to rotate it before I get that same looking figure back? So how many degrees did I just rotate right there? That's what I need your help with. Right, that's what carry it onto itself means. It means how many degrees can you rotate this figure so that you get the original looking figure back. Okay? And here's the easy way around it. Hey, if I went all the way around, I go all the way around. How many degrees did I just go? Everyone agrees 360 if I go all the way around. So that's an easy answer, but that's never going to be a choice. I could always go 360 and get the same one back. But remember, all the angles are the same. Next question for you. How many times would I need to rotate this figure to get back to the beginning? 1, 2, 3. Anybody know what it's going to end up being? 4. Actually, I should have started. Actually, I can't because it's going to stay there.
I have a question.
Sure, go ahead.
So is it rotating until it looks like that, or is it rotating?
I want that same looking. I don't want the exact one back, but I want something that better look like. Here you go. This would not cut it, Abbott, right? That doesn't look like my original. But if I kept going, that looks like the original. Okay.
So you don't need to go all the way back to the original point.
No, because 360 an answer? Yes, but I'm telling you, it's never going to be a choice. That's the easy way out. What I'm asking you guys now is how many turns would I need to make to get back to the original? How many turns of this figure would I need to go? Well, I go from here to here. There's one, and I get the figure back. I go from here to here. I get the figure back. Anybody catching up what I'm putting down here? How many times am I going to have to turn it to get back to the original? 5, which is also the number of what? Yeah, there you go. So 360 divided by 5, that'll give you the smallest number of degrees I can rotate, which would be what? 360 divided by 5? Not doing these for free here.
72.
72 degrees. That's not a choice, though. Help me. That's not a choice. 72, I could rotate it, and then I could rotate it another 72, and I'd get that same figure back. What am I up to now? 72, 72, I'm up to 144. Still not a choice. Rotate it again, how many degrees? 72 degrees again, and I'm up to what? 216. There's the choice. So I'm going to take 360 divided by the number of sides, and if that's not a choice, I keep adding it on every time. Because you could go 72, you could go 144, you could go 216. Keep adding 72. This is how many degree measures I could rotate and get this same pentagon back. All right. Last one I want to go over with you is in the back there. Number 8. I just want to make sure you guys should have no issues with these. I just want to make sure you are good with the notation. Look at part B for me, please. Part B. You guys help me out. What's the lowercase r telling me? Reflection. What's the subscript? I want you to reflect over what line? HF. Everyone good? And then what are you reflecting? Point B. That's what this says. It says take point B, and reflect it over H line HF. Where do you end up? All right, so this is not on the XY axis here. Using this diagram, if I take point B and reflect it over HF, where does it land on? And let's see. Take a look at your diagram. Flip it over HF. Point B lands on 6. What do you have here? Where does it land? Point well, HF. I want to fold it over HF. All right. I don't want to go over here. C. Now, my answer would have been D, Nate, if I said reflect it over AC, right? But point B, I just fold it over the line and it would match up with point C. So that's what that's what those questions are looking for. All right. All right. So let's get going here. You can start wherever you want. Go back to number 1. Finish this one up. You guys know where the answer key is. This is your review right now. All right. Call me over if you get stuck.